The decision that we will make is that we will reject or we will fail to reject. Those are the two choices we get when we do the hypothesis testing. The key idea is that there is a null and an alternative test. We need to know two things: what type of test are we working with and the significance levels. And then finally we need to look at how do the tests help us conclude, and then what are possible errors. First of all, what is a hypothesis test? It is a procedure for testing a claim. Key idea here: what's the claim regarding a particular population? So here are some examples where we look at this particular parameter. Say we're looking at the average, right? The mean. The mean body temperature of humans is less than 98.6. This is called symbolic form. This is kind of like the English explanation. The one this chapter deals with a lot is the proportion of consumers who are not comfortable with drone deliveries greater than 0.5. Or we could choose a standard deviation one. Okay, so those are three options for claims. Staff software can help us answer this question by coming up with z-stat and p-values. And we can get this either in the TI world or in the hypothesis test results. I haven't yet figured out how to do this on the StatCrunch. Hopefully by tomorrow I'll have figured this out. So we begin by creating the null and the alternative hypothesis. First of all, the null hypothesis, labeled H0. This is the claim about the population being true. Now the claim must include an inequality. All right, whichever is left after you look at the equality, this then is known as the alternative hypothesis. All right, and this will include typically a less than, a greater than, or a not equal to. So here's an example. I guess we'll do the example after we go through all the different procedures that we do for what we call the hypothesis test and the alternative test. It's kind of one and the same. Number one, identify the claim in symbolic form. So write it out using an inequality. Then write the alternative in symbolic form. Next, you're going to establish what is the null hypothesis, and remember that has to have the equal sign. Whatever the other one is, HA, that will be the alternative test. The problem will tell you typically what the significance level needs to be. 0.05% is the most popular, and obviously 1% is stricter than 10%. And it depends in the real world which one is more appropriate to your particular claim that you're making, right? How serious is it? If it's a serious claim, meaning there's health on the line, then obviously you want something stricter. Fifth, this is probably the easiest part of it, is you identify the test stat that you need to work on. And there's 4 options. Looks like there's 3 here, but there's actually 4 of them. Now here comes the tricky part. You have 2 options, and again, you can go either way, whether you do the p-value or the critical value. You need to be comfortable doing both. In both options, you will graph with the test stat and the p-value. Then you make a decision. And the decision is, like I predicted at the beginning, that you will either reject the null hypothesis or you fail to reject the null hypothesis. And that's if the p-value is less than our tolerance or if the p-value is greater than. Same with the critical value. Draw the graph, and then we again make our decision, and the decision is either to reject if you are in the region, or you fail to reject if the test stat is not in the region. Finally, the last thing you'll want to do is restate your result from line 6 or step 6 in simple terms. So you can't use any fancy words that we have learned here. It's something anybody should be able to understand. And we need to mention the original claim somehow in there. All right? Confidence interval. This was largely a domain of Chapter 7. And this is a backup technique that we use to confirm our alternative test. But you recall looking at the bell curve and the significance levels and the proportion of the population that is not in those tails, right? Okay. An example, in a survey of 1,009 Americans, 545 were uncomfortable with drone deliveries. So machines dropping off stuff for you. Here is our proportion. Here is that converted into some sort of decimal. So the claim is more than half. So the alternative in symbolic form is less than or equal to a half. All right? Together, these have to occupy the 100%. Since the alternative has the equal sign, then H sub 0, the null hypothesis, is P equals 5. Therefore, our alternative, our original claim is the alternative claim. Kind of an odd way that we go about that. Then we have to look and find the significance level. Most of the time, in fact, I think all the time, this is going to be given to you, so there isn't like you have to guess. But you do need to think about, like, this would be a less critical significance level than that would. Okay? So more serious topics are dealt with at a higher significance level. Because we're looking at a probability that we're rejecting something, we want to make sure that we reject appropriately, if that makes sense. So here now we are into step 4, selecting our test stat. And here are the 4. So we got proportions and 2 options for means, and then obviously 1 standard deviation. So notice 2 of them use a z-stat. And that's if you know, for example, the population parameter, right? Whereas if you don't, then use the t-chart. Okay? Oh, excuse me, big yawn. So this is the one math thing that you're doing in this particular test. So your test statistic is the value that's used to make a judgment, and it's either z, t, or chi-squared. So back to our drones example. More than 50% are uncomfortable, correct? So we're going to use the z-stat. And again, this is because we're doing a proportion. All right, here we go. So there's our n, there's our p. We figure out the q. Again, q is like the complement of p. Here's our p hat. And we plug all these data points values into here, and we get a z of 0.255. So if you remember, that's going to be way over here to the right. All right. When we look this up in the table, we'll generate this value, but we actually are interested in the value that is here. All right. Which tail do we use? Do we use the left, right, or a two-tailed? So a critical region is the area that corresponds to the value that causes us to reject the null hypothesis. So key here is look at your alternative to determine which test. in this case, our alternative said greater than. So therefore, this is the right tail test that we'll be using for our particular one. The p-value test. Remember, there's two different tests you can do. For the p-value test, we want to find the probability of getting a test stat value that is at least as extreme as the test value from the sample. So the critical area is the right tail, and we will want to get a p-value that's equal to the area to the right of the test stat. So back to the drone, we've got a z-value of 2.55, and I looked that up on the table. That's the A2 table, and we get this 0.0054. Let me see if I can find that kind of quick. All right, go back to photos, and here we are. I believe we're looking for 2.55. So here's, can't really draw on here, but you can hopefully see 2.55, and I'm kind of trying to make it as large as possible. And it's in the lower right corner there, 0.9946. Can you see it? 0.9946. All right, so if you come back then to here and you subtract from 1, that's where I'm getting 1 minus 0.9946, I think is what I said, right? So that's what gets me that. We're going to round that off to 5,000ths. And so this is our critical value, p-val, right? So we need, this is where we're sitting at with this particular example that we're working on. Now, one word of caution, we're throwing around a lot of p's. There's p hat, which is our sample proportion. There's our true population proportion, p. And then there's our p-value, which is the probability of the test stat. And our probability of the test stat in this case is 5,000ths. There is a little bit of controversy surrounding p-values, such that there's a particular research magazine that will not print studies where using p-values. And that'll kind of come out a little bit in the end, where there's possibilities for errors. But enough of the community still feels that this is one of many valid techniques, and you can't rely on this null hypothesis and p-values as your only reason, but it certainly is one of the pieces that is looked at, right, to lend support to a particular argument. All right, what critical values? It's the value, remember, that separates the area that is significant from the rest. So in our drone, find the critical value and we'll make our decision. Therefore, we use our alpha. Remember, this is our no confidence region, 5%, and that's going to get us a z-value of 1.645. Remember, we go online and we're going to look for 5% of the data here, 5% of the area, right? And that gives us, again, that same chart, 1.645. Now, we know that z-score 2.55 is way to the right. So this is in my kind of rare circumstance, right? And this leads us then, we reject our null hypothesis, okay? This is not credible because it's way out there in left field. So our summary then is we have sufficient data, evidence, to support the claim that more than half the Americans are uncomfortable with drone deliveries. We could also say we have sufficient enough data to support the claim that we deny that half of the Americans are either uncomfortable or comfortable with drone deliveries. Okay? But it's best to state it in the positive sense here, and we try to state this as simply as we can. Keep in mind there's actually 4 options when you go through here. Not only can you accept, reject, or fail to reject, right? Notice we have here reject, reject, fail to reject, reject. Sorry, there was another. Fail to reject, right? Okay, so we have 4 options. Now the question is, did we include or did we not include the equality symbol in my original claim? And in this case, because we include equality in my original claim, there is sufficient evidence to warrant a rejection of the claim. All right? All right, notice they all refer to H sub 0. Finally, confidence intervals. This is the topic of the last chapter, and this is additional confirmation that the p-test is working. So it helps us reject a parameter that is not included in this interval. Now, in the proportion parameter, we have to be careful because the confidence interval may conflict with the p-test or the critical region test. So this is something that we would build and we would use to confirm whether it backs up our alternative or the null rejection. But after all that, having done that, we may still have errors in our problem. And more on like, why does this error occur in just a second. But there's 2 types of categories of errors. There's what we would call an alpha and a beta error. So an alpha error is that we reject H sub 0, which is true. So this is kind of sad. We say, no, H sub 0 is false, when in fact it's true, and this is committing what we would call a type 1 error. All right, the null hypothesis is true, but we have neglected it. We have rejected it. Now a type 2 error is just the opposite, where we have failed to reject when H sub 0 is false. So we accept it. Yeah? So another example, this is not the drone, but this is like births of a girl, improving probabilities of that. If we were to have a probability that's greater than 0.5, this would give us these 2 claims, right? The null and the alternative claim. So a type 1 error would say, all right, you have rejected a true null hypothesis. So this was true, but you rejected it, which would imply that the sample evidence leads us to conclude that the procedure is effective, when in fact it really isn't. And a type 2 error is that we fail to reject H sub 0, and H sub 0 is false. So in reality, the probability is greater than 0.5, and there is evidence that supports the procedure is effective, and here we concluded that it isn't effective. That's a type 2 error. They're going to ask you to identify those. That's not actually going to happen to you as you do your work, but that explains a little bit about the controversy surrounding p-tests. And the way that people control this is they look at these 3 variables, if you will, the sample size, alpha, and beta. And if you find any 2 of them, you can determine the 3rd. So the trick is choose the largest alpha you can tolerate, which will also decrease your sample size. And then this determines your beta, which is referred to as the power of the analysis. Don't worry, you don't need to know that. Okay? And there's other options too here, but I'm not going to go through those right now. All right, well, best of luck as you go through your homework. and go through the basics of hypothesis testing.